Okay, geographers, plugging away. Video 3, dealing with our hurricane analysis, damage, all of that stuff. So to start this video, we've already gone through and projected everything, which is, as I said in the last video, something you should be doing every single time you're going to do some kind of spatial analysis. All right, so went through, got it all to that UTM Zone 16 NAD 1983. Had to do our raster data separately, but we did it. So in this Hurricane geodatabase, I've got my stuff. I've got my new things right here, which means I now can just ignore this Katrina.gdb. So make sure you're only working with this stuff here. If it helps, go ahead and just delete that because we shouldn't need it anymore. Worst case scenario, if you realize, oops, I made a horrible mistake, you re-download the thing from Canvas and you're good. Okay, but this is the stuff we're going to be working with. And a few things. Actually, let's clean this up a little bit. To start with, I'm going to go ahead and remove. Let's get rid of places, hospitals, churches, streets. Remember, let's get rid of all these points and lines. I'm going to click the top, left click once, shift, and holding shift and left click down here at railroads to grab all of them. And a right click and remove just to kind of make it a little less busy on here. I'm also going to go ahead, this world topographic and world hillshade that they force onto me. I don't like that. I don't want it. I'm going to remove that just to get it out of there. And I'm going to go ahead and hit save because I've done some stuff. Let's remove airports. I want counties. I definitely want that. Yeah, we'll leave that. Well, no, let's just remove. We can always add it back. Remove all of that. I'm going to keep counties right here. What I'm going to do is left click on the swatch. Just do black. Outline. And stop there. Yeah, that's good enough. So it's there, but I can see the underlying stuff. Okay, and I'm going to hit save. Now, what I'm going to do, and I simply did that just to I got a lot of stuff, and I don't need all of it right now. So just because I have it doesn't mean I need to be staring at it. So just try to simplify. And let's uncheck land cover. So we're simply looking at our digital elevation model, a DEM. So it's showing the elevation values for the area. The lighter the color, the higher the elevation. That's what we're looking at. And this is a raster. If I zoom out, it's this rectangular shape. And if I zoom in, let's see if I can get in tight. You should be able to see this in the video. But if you go in, what you'll see are all of these squares. It pixelates as you start to zoom in. That's what a raster is, right? It's a series of grid cells that have some value. And in this case, the value is the elevation. So that's all it is. Each square represents, because the county, hold on. Let me just do this. It'll be easier. It's like that square there. The pixel value is 46.092964. Okay, that's what looking at there. And this one is a different value and so on. That's all elevation that we're looking at. Okay, and these squares are based on a certain value. This is what we mean when we say the resolution of a. Hold on, let me pull this up. Let's measure distance. The resolution of get out of there of a raster image, we mean how big are these cells in here, these pixels, however you want to think about it. And if I use this measure tool to go from here to here, it's roughly 30-meter resolution that we're dealing with. If I really cared, I could get in tight to it, but you get the general idea. So meaning that each square represents 30 meters by 30 meters, okay? Which is perfectly fine for what we're doing here. If I zoom out, if I'm looking at the entire coastal part of Mississippi, yeah, that works. It's going to show me what I want. If I were simply looking at, one beach or one area within here and the damage there, this might be too coarse, might not actually be useful. But of course, you don't always have access to incredible, 2 centimeter or 6-inch resolution raster imagery. It can be quite expensive. So quite often, the free stuff that you have, if you're not working for some government agency that had the money to get the high quality stuff, you're going to be working at 30-meter, at best 10-meter resolution. But again, works for what we're doing here. Okay, so what we want to do, let me go back to this analysis tab. When we're working with anything, but especially with these rasters, it's good to, as the book chapter points out, go into your environments. And I think, let me pull up our PDF. Yeah, it's getting in to do this through Arc Toolbox. So the step 4, set up the environments. We don't do it in the Arc Toolbox way. Just go to Analysis. I guess, it's kind of connected here. But anyway, and click on Environments. And it brings up this window. And you've got some stuff that you can fill out. Some things will be blank. Some things will have some defaults put in here. In terms of workspace, it's where do you want things to be saved to, just by default. Current workspace, Scratch workspace, it's kind of more of a temporary thing here. But it's going to our, let me click back to catalog so we can see this. So it's saying, you want us to save everything in this Hurricane geodatabase? Sure I do. That works. So I'm going to leave that. Output coordinates. If I'm producing something, doing some kind of geoprocessing, run some tool, and I make some new data set, what should the coordinate system of that new data set be, right? Or feature class, or new raster, or whatever it is. So it's blank now, but I can select, any of these should work because they're all the same, and I'm going to select counties just to say, look, I want everything in this NAD 83 UTM zone 16, just to help out. The geographic transformation, this is going from one datum to another. We're not going to worry about this. We'll let that show up. It's not really important for what we're doing here, so we'll just leave that. And if it were important because we extended this with some new data sets that had new datums and all that, it would ask us what we want to do at the time, and we could worry about that. So we'll leave that there. Processing extent, we'll leave that, but come down here to raster analysis. So we should be able to do everything in here. Raster analysis, and if any of these are, look like that, just hit the little drop down thing. With cell size, this is saying, hey, if you're taking a couple of rasters or doing something with one raster, making a new raster, whatever, with that new raster, what should the resolution be? That's what cell size means. Your options are maximum of inputs, minimum of inputs, and then it has, any of your existing ones in here. Now the book, let's close that. I believe, set cell size to 30. I don't even know if we can do that anymore. And that would be bad. Even if we could do that, I want to do that because you're potentially lying as you go about stuff here. And the idea being, if I just put 30, It's going to say all of my rasters are going to have this 30-meter resolution. I don't want that because I don't know exactly what's what. In fact, some of these, I think one of them was like 29 point something. It wasn't actually 30. I never want to force a resolution on something that doesn't already have that resolution. So if I leave it at maximum of inputs, what it's saying is if I'm taking a couple of rasters and I'm doing some math, doing some analysis, whatever, I'm producing a new one, give it the worst resolution of the two or the multiple rasters that I'm dealing with, right? Maximum of input, meaning, if one is 30-meter resolution and another one is 40-meter resolution, go with the 40, the coarser one, right? It's a lot safer to default to the worst resolution of the bunch than to force everything to the good resolution, because you're just lying when you take coarse resolution and just make it fine without actually doing anything to it. Right? I don't know if this fully makes sense or if it's a little too theoretical with this stuff, but basically, for now, we'll move on. It's just the idea is stick with maximum of inputs. Okay, all of this stuff we can leave, but what I want to do here is for mask. See this doesn't give me any pictures, but it's basically saying, look, when you're doing this work, make sure that it's any stuff I do here, fit it to a specific area, clip it effectively. And this is useful. So I'm going to hit browse, and I'm going to select counties. Okay? Actually, and I'm going to make sure, that was from this Katrina geodatabase. Let's go back to folders. I want it from my good counties. So I'm going all the way back, going in here, this counties, and hitting OK. And it's saying, so when I start to do some stuff here, only do the math, do the work within these counties here. Get rid of this extraneous stuff. All I care about is what's happening in these, I think it's 3 Mississippi counties that are down here. Okay, so we'll do that. The other stuff, I think we'll be okay. If not, does this already have? Let's do that too. Let's try it just to be safe. So processing extent, hit this extent of a layer, select counties there. Just sometimes, even if I put the mask as counties, it doesn't quite work, so we'll do both. I'm going to hit OK, and I'm going to hit save up here. And in fact, let me turn this back on. I'll change the color so we can see it, just to make sure what I'm talking about. So the idea, here are 3 Mississippi counties. We're only interested in working within these. So the stuff that leaves the county, leaves the state, goes into the ocean, whatever, don't care about it. Okay, that's what we're doing here. That's the idea with this stuff. And that's the idea where it's saying get into the environments and set all this stuff. It makes life easier and it looks a little more slick as we go through. Okay, so save what you got. Once you've done this stuff, then this analysis in this tutorial gets into, all right, let's do some work. And this first one, display the Mississippi coast elevation, bathymetry, hydrography, all that. Skip it. I mean, you can look through it if you want, but it's basically saying, like, turn on some layers, do some stuff. Might be useful to have an overall reference map if you're delivering this to your stakeholders and all that stuff, but we're not going to worry about that. You should be able to do that kind of stuff based on completing some of these other classes. What we want to do is let's move on to some real spatial analysis. Right? Step 2, calculate flooded land. And with this, to go through, again, this ArcGIS desktop versus the ArcGIS Pro stuff. A little different. Open a new map document and save it as Coast 2. We don't have to do that. We can make multiple maps in here now. Used to be you'd have different, what were called MXD files. In here, we can do whatever we want. Right? So what I'm going to do is just right click here, go into Properties, and under Name, I'll call this one, I mean, it says Coast 2. I guess we can do it just to follow along. I would probably call it, flooded land or something like that. But I'll hit OK. All right, so that's Coast 2. And the reason for this is so I can come in later if I've got multiple map frames and multiple layouts. It'll make sense. So you would just want to name this whatever made sense to you. But in here, it's saying this is to calculate our flooded land. And go back, document your map, data frame, set the environments. We just set the environment, so we're good there. It asks you to turn on your Spatial Analyst extension. Now you should have this set up as you loaded everything, and if you did the complete install. The way to get to it, let's see, it's project licensing. You should have it licensed right here, Spatial Analyst. So these extensions are extra bits of software, extra tools, and things like that extend ArcGIS Pro. And this was one of their best ways of figuring out how to take as much money from government agencies as possible. Is say, yeah, we'll sell you this incredibly expensive software that can do a lot of what you need to do. But that one thing that you really need to do, it's going to be a few more $1,000s per computer, just to get the Spatial Analyst extension, right? Or the Image Analyst extension, or whatever. All these do slightly different things, and the way they're selling and licensing stuff, it's all kind of just blended together. But still, trust no one with this stuff. But of all of these, Spatial Analyst is the one. Like if you could only have one of these extensions, this is the useful one, at least in terms of the kind of stuff I've always done in a variety of jobs. Really useful. So you want to make sure that this licensed says yes. If not, let me know, because it's more of an issue of I got to talk to the school and we got to pay some money and all that. But you should have that, guys. So just double check that. So what Spatial Analyst is saying, it's a series of tools. And what you can do in here, we were searching stuff, but if you just hit the back or cancel it or whatever and click on toolboxes right here, it gives you all of the different tools that ArcGIS has from which to choose. And if you scroll down, you can open up Spatial Analyst tools. And within here, there's a lot of stuff. And we're going to use just a few of these things today and in other assignments in this class. But there's a lot that you can do. Primarily, this is all based on raster data and dealing with something like a digital elevation model like we're looking at here. We can do stuff to it. We can extract information from it. We can start to get answers from this stuff, right? So that's the power of this extension. And so what we're going to do first is this is going to be pretty simple, but we're going to take this elevation data set, our eliv_Katrina, and we're going to get it out of meters, right, which is what these numbers represent. The actual elevation in meters, and we're going to turn it to feet. Why are we going to turn it to feet? We are dealing with politicians and government officials, not scientists and not Europeans or somebody like that. We're dealing with people who think in inches, feet, miles, that kind of stuff. So if you say it's 40 meters above sea level, that doesn't mean anything, right? So we're just going to convert this stuff. Okay, that's the first goal here. So what we'll do is we can search for this stuff, but I kind of like just you seeing all of this stuff here. So instead of searching, go in from here, Spatial Analyst Tools, open up the Math tool set. And I know you're like, yeah, finally, let's do some math, because that's what these classes have been missing. Not enough math. Don't worry, this is easy. This is all simple stuff. Don't flip out with it. But all we're going to do is we're going to use the times tool to convert from meters to feet. Okay, so I'm just going to double click times. And so my, let me move some things around. It's pretty simple. My options here are just what's the input raster? You know, is there a second one here, and what's the output? So the first input here is going to be my elevation. Okay. My second one, I'm not going to hit the drop down. I'm instead going to type in 3.28, which is my conversion factor to go from meters to feet. Okay, so I'm just saying, take every cell in this elevation data set and multiply that number by 3.28. And then the new file, what are we even doing right here? I'm not going to do that. I'm going to call it, I'll get rid of that times, elevation. And sometimes it's a case where these rasters, they have limitations on what you can call them and character length. I think I can get away with this. I'm just going to call it elevation Katrina, but I'm also going to put feet at the end so I'm not confused. And I'm going to hit run. If it all works, this is always the fun part. Let's uncheck that. Yeah. Yeah. Look at that. So what it did, this is that mask thing. And I'm excited about this because no matter what, and we could be doing this in a classroom setting, and 95% of us would have it work. And then there'd be like that one person who's like, I did it and it didn't work. It's a mystery. There's a little hope and prayer involved with some of this stuff, but this works. So that's what the whole mask thing is for here. It's to get rid of that extraneous stuff, because again, I'm interested in these countings. This is where I'm studying this stuff. I don't need all of these extra things here. It also looks kind of cool to not have some big rectangle, to have it fit the actual shapes themselves. All right, and so the value itself, the math, has worked here. It's changed the values. So now this value that we're looking at, 270.771, that's feet. That's the maximum elevation for this area. And you could go like, well, wait a second. If I multiply 103 times 328, shouldn't that be higher than that? Yeah, maybe. Not maybe. Yeah, that's correct. But there's a good chance that value is, say, up here, right? So keep that in mind. We can't directly compare these two raster sets or these data ranges because we clipped it. You follow? All right, let's go ahead and hit save. But that's awesome. We did something here. Now, the next thing we can do, because we're interested in, flooding, right? Is we can look at this based on the elevation and based on our storm surge. What happened, right? What was flooded when the hurricane came in? And storm surge refers to these hurricanes. They're just sucking up water and heat, energy, and all this stuff from the ocean itself as they're moving along, and they pull up the ocean and they bring it on shore. So the flooding isn't because of the rain or whatever. It's because the ocean is literally pulled up and brought onto land. So the storm surge, which I mentioned in the previous videos, 15 feet for Katrina here, for this specific part of the Gulf Coast that we're looking at. Okay, so what we're going to look at is say, okay, what's less than 15 feet, right? If the elevation is less than 15, it means it was flooded during the storm. All right, so what we're going to do, let's go, if I go back here, okay, within, this same math tool set, so the terminology, it's a toolbox when it's got that icon. The little tray with the hammer is a tool set, and the individual hammer, and I don't see it here, sometimes there's a little script icon, but that's the tool itself. With this one, we're going to open up logical. And what logical refers to is where you're making some statement or argument using logical reasoning. And what we want to say is show us all of the land here that's less than or equal to 15 feet. Right? Meaning that if it's 15 feet or below, it'll be flooded. And anything that doesn't fit that will not be flooded. So find the less than or equal tool, less than equal, right there. Okay, and so what we're going to put is this elevation feet, one that we just created. Okay, input 2 is just going to be 15. And instead of less than, whatever, I'm just going to call this flooded land Katrina. Again, putting the Katrina thing here because the Hurricane Wilma exercise is 4.2. I'm going to hit run. Let's see what happens. Gorgeous. This is what I want to see right here. Yours might be this gray and red motif. It might be a different color, but the main thing is we've got 0 and we've got 1. Color's irrelevant here, but what we want is 0 and 1. It's a true false situation. Or we're going to look at it as 1 means flooded, 0 means not flooded or dry. So what it's showing here is all of the elevation that is less than or equal to 15 feet. And that's what was flooded. You follow? That's actually pretty cool what we're able to do. This doesn't involve us going, to the scene, going around, driving around, mapping out what was flooded or whatever, but pretty instantly, just based on the storm surge values we were given, figuring out what was flooded, what wasn't flooded. And it doesn't mean that there wasn't damage to structures, in this gray area. We have winds, we have rain, trees falling down, all sorts of stuff can still happen, but this at least tells us where was that storm surge damage. All right, so go ahead and hit save right off the bat. This is some cool stuff, but I'm going to stop this one because I think we've been going for about 30 minutes or so here, trying to keep these in manageable chunks. We'll save this. But then the next video, that's where the good stuff is really going to happen and where we can start to get into some of what's going on. And feel free as well, I encourage you, I'm going to go through and point out this whole reclassification thing and dealing with land cover. And let me find this here. So see, this is the stuff we just did. I walked you through it. But it's more or less the same process, right? In different spots, looks a little different. What you see on your screen versus these old screenshots. But try to read through here. See if you can make sense of it. So like this step 3, reclassify national land cover. This part is tedious and it sucks. But we're gonna do it. But look at it. See if you can get a sense of what's actually going on here. We're going to use this reclassify tool to reclassify these weird numbers that exist. Here, let me do this. Return the land cover, all the 0, 1 to 11, blah, 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 that kind of mean nothing. This is what it actually means here. So like this 11 means open water. And we're going to change it from 11 to this value of 1. 21 developed open space, 22 developed low intensity. We're just going to reclassify these 3, or actually 4, to this value 2. That's just going to mean developed land. We don't care about how intensely it was developed. So the idea is taking this very confusing, very daunting data set here and making it into something more meaningful for this part of the world. Okay, so I say that, I'm going to stop the video. I'll have another video going through this, but I encourage you to look through, see if you can do this on your own. See if you can make it work where you get these new values. And what we'll ultimately do as you go through here is look at, flooded land, stuff that was flooded, but like separate that by land cover to get a sense how much stuff that was flooded was agricultural or this developed stuff or whatever. See if you can go through and do it. And if not, if it's not quite working, you're running into trouble, check out the video, right? To really force yourself to try to learn this stuff. That's the goal, is to not have me walking you through stuff always, but trying to figure it out, do a little problem solving, think about this stuff. Think like a GIS professional. All right? All right. See you in the next video.